Hello everybody, this is Mr. McNair, and this is going to be a short video on multiplication properties of exponents. First, let's deal with this number 4 to the third. 4 to the third has a couple of parts. The first part we're going to deal with is the 4. That 4 is called the base. Good. Next, let's deal with the 3. The 3 is called the exponent. And the last part we'll deal with is the whole thing. The whole thing is called a power. Good. Now, what does 4 to the third actually mean? Well, it actually means, in expanded form, 4 times 4 times 4. Okay? So, knowing that 4 to the third means 4 times 4 times 4, and if I was to drop down this multiplication symbol, and I know 4 squared means 4 times 4, if I told you to write 4 to the third times 4 squared as a power, you should be able to say, okay, well, that's 3 4s here, 2 4s here. That's a total of 5 4s, so that's 4 to the fifth. But you could have skipped that step, skipped the step of expanding it, and noticed that we could just add the exponents and keep the base the same. Alright, that property is called the product of powers property. Whenever you multiply powers with the same base, now that's a big part of this property. They have to be with the same base. Whenever you multiply powers with the same base, you add the exponents. So, in part A here, 3 to the fourth times 3 to the sixth, those have the same base, is 3. And then you just add the exponents. 4 plus 6, that's 10. Notice that the base, once again, it does not change. Okay. In part B, the bases are the same, x and x. And the exponents are 1 and 6. So the base is x. You add the exponents together, and you get 7. Okay. Good. Next problem, 2 squared cubed. Now, if we were to expand this, you would be able to say, okay, well, because this is cubed, that means we're multiplying 2 squared times itself 3 times. All right? And then if we expanded it even more, we would say, okay, well, 2 squared is 2 times 2. 2 squared is 2 times 2. 2 squared is 2 times 2. And then we could just drop down these multiplication symbols. So we have a total of 2 to the 6. But if you noticed at the beginning, the exponents are 2 and 3. Well, what did we do with those exponents? Well, we kept the base the same, and we multiplied the exponents together. That's called the power of a power property. Whenever you raise a power to an exponent, you can multiply. You can multiply the exponents together. All right? Good. So, in part A here, we're raising a power to a power, so that's going to be y to the 20th. Just multiply those exponents. B, same thing. Raising a power to a power, the base is going to stay the same, and we multiply the exponents together. C, the base is going to stay the same, it's -4. And then once again, we multiply the exponents together. Okay? Great. Next, 2 times 3 raised to the 4th power. Now, if I was to expand this out, you would say, okay, well, 2 times 3 to the 4th power is like having 2 times 3 being multiplied by itself 4 times. So that leaves us with how many 2's? Well, 1, 2, 3, 4. So that's 2 to the 4th. And how many 3's? Well, that's 1, 2, 3, 4. 3 to the 4th. But if you recognize at the beginning, what you could have done is just taken this 4 and distributed it to the factors. 2 to the 4th times 3 to the 4th. Okay? So you don't have to do the expanded form. That's called the power of a product property. You can distribute an exponent into the factors of a product. Now this is important, the factors of a product. You can distribute them, the exponent, when the terms on the inside are being multiplied together. All right? It has to be multiplication. It has to be multiplication. Notice that we couldn't have done it in a problem like this because they weren't being multiplied, they were being added. We're not dealing with addition. You can't distribute there. You can only do it when they're being multiplied together. And later on, we'll talk about you could do it with division also. But definitely not addition or subtraction. Here, let's deal with this. So take this 2. We're going to distribute it into the parentheses. It's being multiplied together, so we know we can do that. So that's 3 squared times 7 squared. This one, they said write it as a power and as an integer if possible. So let's keep simplifying. 3 squared is 9. 7 squared is 49. And if we multiply those numbers together, you get 441. Alright, B. Same thing. Take this 3, distribute it into the parentheses. So we get negative 5 to the third. Whenever you distribute an exponent to a negative number, put the negative number in parentheses. Always do that. Always do that. A to the third. Negative 5 to the third is negative 125. And we have a to the third. Same thing that we're going to do here in part C. Take that 2, distribute it to the negative 2 and the w. So we have negative 2 squared. Once again, whenever you take an exponent and distribute it to a negative, put it in parentheses. Alright, negative 2 squared is 4, so that's 4w squared. Now, part D here. Notice that there's negative on the outside. Well, it's on the outside, so this 2 is not going to be distributed to that. The 2 is going to be distributed to everything on the inside. So we would have 2 squared w squared, and then we're just going to drop down that negative. 2 squared is 4. W squared is w squared, and once again, we're going to drop down that negative. So our answer is negative 4w squared. A lot of times when I deal with negatives on the outside of a parentheses, I like to think of them as being a negative 1. It's like you're multiplying your answer by negative 1. Okay? Good. Now, some people might be asking already, well, is there a difference between negative 2 squared in parentheses and negative 2 squared without the parentheses? Why do you tell me when I distribute an exponent to a negative to put it in parentheses? Well, if you type it in your calculator will recognize the difference. And it looks like I typed it in already. But just to prove it to you again, negative 2 in parentheses squared, well, that is 4. Negative 2 squared without the parentheses, that's negative 4. Okay? And the reason why that is because negative 2 squared, well, in parentheses, the base is negative 2. So this really means negative 2 times negative 2. And we know a negative times a negative is a positive, so that would be positive 4. Over here, on the right side of the screen, the base is just 2. It's not negative 2, it's just 2. So this is really 2 times 2, drop down the negative, make it negative. 2 times 2 is 4, and that's for negative 4. Okay? Alright, let's do a little bit of simplifying here. In part A, we take this 3, do what with it? Distribute, good. So we would have 4 to the third, x to the what? 6, right? Because we're multiplying the exponents together. Y to the third, and then we're going to multiply by x to the fifth. Let's go ahead and simplify a little bit more here. 4 to the third, well, we know that is 64. X to the 6 and x to the fifth, well, because those are being multiplied together and they have the same base, all we have to do is add the exponents. 6 plus 5 is 11. Okay, and then we have the y to the third left over. Okay, and then that is our final answer. Alright, let's do the same thing with B. This 3 distributes into the parentheses. So, once again, negative numbers, when you distribute an exponent to it, keep them in parentheses. Negative 3 to the third, x to the third, y to the 6. Over here, on the right side of this expression, this 2 goes into the parentheses. So, negative 2 in parentheses squared, x to the fourth, y squared. Let's just deal with the numbers real quick. Negative 3 to the third, well, we know that that's negative 27. And then I'm just going to drop down everything else, the x to the third and the y to the 6. Negative 2 squared, well, that's positive 4. And then I'm going to drop down my x to the fourth and y squared. Okay, let's go ahead and multiply the things that are similar. Negative 27 times 4, that's negative 108. Multiply our coefficients together. Let's multiply our x's together. X to the third times x to the fourth, that's x to the seventh. We're just adding the exponents. And then y to the sixth times y squared, that's y to the eighth. And there you go. There's our answer. Alright, last problem. This problem wants you to simplify, then evaluate the expression when a equals 1 and b equals 2. So let's go ahead and simplify this. In part A, b squared times b to the third, we know that's b to the fifth because we're multiplying two things with the same base. And then we're just going to do b squared to the fourth. Well, we're raising a power to a power, so we multiply these two exponents. 2 times 4, well, that's 8. And now, once again, we're multiplying two things with the same base, so we add the exponents. So we have b to the 13th. Alright, so that's the simplified answer. Now we're going to take the fact that b equals 2, and we're going to plug it in for b. Right? So, 2 to the 13th. Let's go ahead and type that in our calculator here. 2 to the 13th is 8,192. So, this is 8,192. Great. Alright. Part B. Once again, sometimes when there's a negative on the outside, I like to put a little negative 1 out there just to know that that's the value. So we have negative 1. We're going to take this 2, distribute it into the parentheses. So that'd be a squared times b to the 6. Alright, and that's about as simplified as we can go. Now we're going to evaluate our expression, plugging in 1 for a and 2 for b. Okay? So, negative 1 times a is 1, so that's 1 squared, times b is 2, so that's 2 to the 6. So, negative 1 times, what's 1 squared? Well, that's 1. Times, what's 2 to the 6? Well, that is 64. Alright, 1 times 64, that's 64. 64 times negative 1 is negative 64. And there's our answer. Okay? Alright, I hope that this video has helped you out. And have a wonderful day.